Salutations. I'm Jesco, and you're watching Game Dev Made Easy. Today's topic is implementing the state pattern in Unity. The state pattern is a design pattern that allows for an object to appear to change classes at runtime. You can think of the state pattern as an alternative to a state machine. The end results are very similar, but the way you write them are very different. The state pattern is designed to be more loosely coupled from your code base, so it is far easier to use it in different projects. The state machine is much more tightly coupled from the code base and is better suited for a specific project. With all of that out of the way, roll the information about Writer and the intro.
This video utilizes JetBrains Writer. Writer is an IDE based on IntelliJ and ReSharper that was included in my subscription that JetBrains gave me for 1 year. Writer is cross-platform for Windows, macOS, and Linux. It supports the .NET Framework, .NET Core, and Mono-based projects. In other words, you can build .NET projects, Mono projects, and work with Unity in it. It has many features, including code analysis, code editing, refactoring, unit test runner, debuggers, database and SQL, navigation and search, front-end technologies, and is highly extensible with plugins. Writer by itself costs $139 per year with the perpetual fallback license, or $13.90 per month. Writer does require some setup before it works the way you would like for it to, but it is a great alternative to Visual Studio for cross-platform development with C#, JavaScript, F#, and Visual Basic.NET.
The object of this video is to have as similar of an implementation and as similar a result as possible to the CryEngine video. Now, obviously things will have to be a little different as some functions don't exist in the other engine or have different names. I'm just making sure we are all on the same page here. We will have the same classes and for the most part the same methods for both engines. We will have a character class, an iCharacter interface, a wait state, a wander state, and a character behavior class. The reason we have everything separated like this is that each .cs file has a specific purpose. The character class will define the context of how the state pattern functions. The iCharacter interface will define our base methods that we want to make sure is always present in our derived classes. The wait state is one of the states that we want the character to move into. In this case, to wait for a few moments before moving on to the next state. The wander state is the other state we want the character to move into. In this particular instance, we want the character to move in a random direction. The character behavior class will derive from the engine-specific class to allow for it to attach to an object in the editor. For Unity, that would be Mono behavior, and for CryEngine, it would be Entity Component. Let's do a quick transition and we will get into the implementation in Unity.
Create a new 3D project in Unity and call it Unity State Pattern. We can begin the fun journey from here. Inside of the Assets folder, create a folder called Code. Now create another folder and call it State Pattern. Inside of the State Pattern folder, create a new C# file and call it iCharacter. Create a second C# file and call it character. The second to last file is called the wait state. The next C# file to create is the wander state. Go up by 1 in the directory tree to create our final C# file, which we will call character behavior. Double-click on the character behavior script to open it up in your editor of choice. I will be using Writer.
Locate the iCharacter script and open it up in the editor. Delete everything from the class file. Your editor should be as blank as mine. The first thing we will do is add using statements using Unity Engine, which will give us access to all pertinent classes, methods, structs, fields, and properties that reside within the Unity Engine namespace. Now we will add our namespace, write namespace character state control, as this organizes all of our code files to be within the same working namespace. The next thing to do is create our interface. Write public interface iCharacter. We will use this as a definition of what we want our states to implement. Inside of this interface, we will only create one method. That method will be public void handle movement with the parameter being vector3 position. Warning, from here on out, I will be implementing things one class at a time instead of the method I used in the CryEngine video. However, when copying the code as seen, expect to see many errors in the project until we get to the character behavior class. Let's continue on. Open the character class and delete everything once again. Next up, we will add the same using statements as before. Using system and using Unity Engine for the same reasons provided before. The same namespace will be used, which is character state control. Write public class character. This is what we would classify as the context of the state pattern, where the implementations are expressly made and giving the information about how the code will function. Inside of the class, write public game object character object. This call will give us a reference to the object that we want to control later in the character behavior class. Next, we need to write private iCharacter and call it state. This allows for us to directly call the handle movement method we defined when we need it. Let's create the constructor for this class. Write public character. Inside of the constructor, write state is set to be new wander state. The parameter for wander state should be set to be this. Obviously, we haven't implemented the wander state class yet, and errors will be thrown for you. Don't worry about it, all will be resolved in time. Next, we will write public void set state with the parameter being iCharacter called new state. Inside of the method, write state is set to be new state. This method will read which states are active based on the calls used by the wander and wait state classes. The next method to create is public void update. This method will be designed to call the handle movement methods we will implement in the wander and wait state classes. Inside of the method, write state.handleMovement with the parameter being characterObject.transform.position. We have two methods left to implement in this class. The first method will be a private vector3 called getDirection. It will take a parameter of vector3 called destination. This method will get the direction that the object needs to travel in. Inside, write return destination minus characterObject.transform.position.normalized. We subtracted destination from the character object's position, which will give us a vector3 value to use. Then we normalize the vector. The final method is the moveTowards method, which, as the name suggests, it will make the object move to the location we desire. Write public void moveTowards with the parameter being vector3 called destination. Inside the method, write var direction is set to be get direction with the parameter being destination. The final thing to write is character object.transform.translate with the parameter being direction multiplied by time.delta time multiplied by 1 float. This completes the character class, and we can move on to the wait state class. Delete everything and start fresh, just as we have done from the very beginning. The two using statements will be the same as before, using system and using Unity Engine. Once again, we will add this to be the same namespace as before. Write namespace character state control. Now, write public class wait state. Add the colon to designate inheritance, and we will inherit from iCharacter. Inside the class, write private character and call it character base state. This will grab a reference to the character class, which we will need in the constructor of this class. Next up, write private float timer is set to 0 float. This will be used to create a timer in the handle movement method. Now we can create the constructor of this class. Write public wait state. The parameter should be character class, and it should be called character. Inside, write character base state is set to be character. The last item within the constructor should be a log call, so we can view the results of this class being activated. Write debug.log, and in quotes write I'm in the wait state. Now we can implement the handle movement method. Write public void handle movement. The parameter should be the same as the interfaces with vector3 called position. Inside the method, write timer plus equals time.delta time. This is going to take the value of the timer and add the results of time.delta time to it. Next up, write if timer is greater than 5 float. This will check if the value of the timer is greater than the value we specified. Inside of the if statement, write character base state dot set state. The parameter will be new wander state, which requires a parameter of its own of character base state. What is happening here is set state requires a type of iCharacter, which we set to be a new instance of the wait state. The wait and wander states both require a parameter of the type character, which will be set in the constructor of the class. Let's move on to the wander state class now. We will start off by deleting everything from the class. I really need to stop repeating myself in these scripts. Right, using system and using Unity Engine, for the reasons we already discussed before. The namespace is, as you probably guessed already, character state control. Write public class wander state, and it should inherit from iCharacter. Inside of the class, write private character, and its name will be character base state. Same reasons as before in the wait state class. We will create a private vector3 called destination. This grabs a reference to the vector3 type that we can pass around as needed. Let's create the constructor for this class. Write public wander state, and the parameters of this method will be character with the name of character. Inside the constructor, write character base state is set to be character. Next up, write destination is set to be getRandomDestination. The getRandomDestination method has not been created yet, but it will be a method that returns a vector3 value. The last item within this constructor is debug.log. Inside of this, write in quotes, I'm in the wander state. Moving on, we can implement our iCharacter interfaces method of public void handle movement with the parameters of vector3 position. Inside, write if destination reached with the parameters of position and destination. Inside of the if statement, write character base state dot set state. The parameter of this will be new wait state, and wait state requires a parameter of character base state. Move outside of the if statement and write character base state dot move towards. The parameter should be destination. Now we can implement our methods that we created in the constructor and within the handle movement method. First up, write public vector3 get random destination. Inside, write return new vector3. The parameter should be unityengine.random.range. The parameter of the random call should be 1 and 15. This is for the x value. Write a comma and write 0 float. This will be for the y value. And finally, we can do the z value, and it will be unityengine.random.range. The parameter of the random call should be 1 and 15. The getRandomDestination method will randomly select an x and z value for the wandering object to have as the destination value. That completes the getRandomDestination method. We can move on to the final method. Write public bool destination reached with the parameter of vector3 current position and vector3 destination. Inside, write return vector3.distance. The parameters of the vector3 distance function will be position and destination. Following this, write the less than symbol with the value of 0.5 to the end of the statement. This destination reached Boolean method is designed to check if the distance between the current position of the object and the destination of the object is less than the value specified. If it is, return true. Otherwise, it will return false. This lets the object know whether it should continue to move or switch to the wait state as defined in the handle movement method. All compiler errors should be fixed at this point if you are using any other IDE than the one I am using. We can now move on to the final class to implement the implementation to get this working. Let's go to the character behavior script. We will keep pretty much everything that is in the class by default. We need to add one using statement to the list though. Write using character state control. This will give us access to all the classes we created within the namespace. Inside of the class, write private character and set the name to be character. Same reasons as before. In the start method, we will write character is set to be a new character. This will initialize the character class and allow for values to be passed between this class and that one. Next up, write character.character object is set to be this.gameObject. This specifies that the object we created in the character class is the object that is attached to this class. Moving on to the update method. Inside, the only thing we need to write is... Moving on to the update method. Inside, the only thing we need to do is write character.update. This will call the update method we defined in the character class. Save everything, and again, all compiler errors should be resolved at this point. Time to move back to the Unity editor at this point to polish things off to complete this. Add a cube to the scene. This will serve as our AI object. Move over to the main camera. It should have the X rotation value of the camera to be set to 75.28. The Y position of the camera should be set to 22.8. Go back to the cube and attach the character behavior to the cube. Everything is now complete. You can press the play button and watch the AI move around on the screen in random directions. Sorry about not uploading this video sooner. However, I was a bit lazy and sick, and wanted to actually utilize my Mac for video. No sense in spending too much money for a MacBook Pro and not using it for content once in a while. If you guys want to see more content that delves into design patterns for AI, UI, or general game mechanics, let me know in the comments below. As always, the link for the GitHub repo for this code is in the description below. I want to thank Coburn and Kupala for their continued support on Patreon. And it is now at the point where they have donated long enough and consistently enough that they can choose a topic for me to cover. So guys, if you're watching, let me know what you'd like for me to do for a one-off video.